Hello students, this is Ma'am Christine. Join me as I discuss to you another lesson in grade 9 mathematics, which is solving quadratic inequalities.
Definition. A quadratic inequality in one variable is an inequality that contains a polynomial degree 2 and can be written in any of the following forms. We have ax squared plus bx plus c greater than 0. We also have ax squared plus bx plus c less than 0. Ax squared plus bx plus c greater than or equal to 0, and ax squared plus bx plus c less than or equal to 0, where a, b, and c are real numbers and a should not be equal to 0. The steps in solving quadratic inequality in one variable. So step 1, we have to make the inequality into an equation, then solve for its roots. Step 2, plot the roots on the number line. Step 3, test point. Step 4, illustrate the solution set, and then for the last step, write the interval notation. Graphing inequalities on a number line, we use open and closed circles to represent the number. So for symbols greater than and less than, we use open circles, and an open circle indicates that we do not include the number. And for greater than or equal to and less than or equal to, we use closed circles, and a closed circle indicates that we include the number. An interval is open if the interval does not contain its endpoints. The symbols parentheses or open and closed parentheses are used to indicate that the endpoint is not included in the interval. And an interval is closed if the interval contains its endpoints. The symbols brackets or open and closed brackets are used to indicate that an endpoint is included in the interval. Example 1. Solve the quadratic inequality x squared minus 2x minus 3 less than 0. So for the first step, we have to make the inequality into an equation, then solve for its roots. So we now have x squared minus 2x minus 3 is equal to 0. Please do remember that we have four ways in solving quadratic equation. The first one is by extracting square roots. The second one, we have factoring. The third one, we have completing the squares. And we have solving quadratic equations by using quadratic formula. So our equation given here can be easily solved using factoring. So I have here, using asterisk method, we have to find first our AC. The value of our A is 1 and the value of our C is negative 3. Multiply those two, the result is negative 3. And we also have the value of our B is negative 2. Next is for us to find factors of negative 3 that if added, the result is the value of B, which is negative 2. The factors of negative 3 that if added is negative 2 are 1 and negative 3. Please take note, 1 times negative 3, the result is negative 3. And if we add those two, 1 plus negative 3, the result is negative 2. Next is for us to divide those factors by the value of our A, which is 1. Divide those factors, simplify, and then change the sign so that we can get the values of our roots. So 1 over 1, that is 1. Change the sign, we have negative 1. Negative 3 over 1, the result is negative 3. Change the sign, so we have positive 3. The values of our roots now are negative 1 and positive 3. After finding the roots, we now have to do step 2, which is to plot the roots on the number line. So let us have a number line. Please take note that both ends of our number line is extended to negative infinity and then to positive infinity. We have to plot the roots. Our roots are -1 and +3. We are using open circle since the inequality symbol given is less than. Now, after plotting, our number line is now divided into 3 intervals. We have the first interval from -infinity to -1, not included. We have from -1, not included, to 3 for the second interval, and then for the third interval, from +3, not included, to the positive infinity. Step 3, we have to test points under the 3 intervals that we had in step 2. So now, by using the graph that we have, to decide for a point value that we have to test. So in first interval, we have here from -1, not included, to the negative infinity. We can use -2, -3, -4, so on and so forth. But in this example, I will be using -2 as our test point value for the first interval.
Now, let us try to test the point value -2 if it satisfies the given inequality x squared minus 2x minus 3 less than 0 by substitution method. So let us substitute -2 in the variable x in this inequality. So we now have -2 squared minus 2 times -2 minus 3 less than 0. Perform the indicated operation, -2 squared. That means -2 times -2, that gives us +4. -2 times -2, that is also +4. Minus 3 less than 0. Now, 4 plus 4, that gives us 8 minus 3 less than 0. 8 minus 3, that gives us 5 less than 0, which does not satisfy the given inequality. That means it is false.
Now, for the second interval, we have -1 not included to +3 not included. We can choose any point under that interval. So in this example, I will be using 0.
Now, let us test the point value 0 if it satisfies the given inequality x squared minus 2x minus 3 less than 0 by substitution method. Let us substitute now 0 to the variable x in the given inequality. So this will now become 0 squared minus 2 times 0 minus 3 less than 0. Perform the indicated operation. This will now become 0 minus 2 times 0, that gives us 0 minus 3 less than 0. Therefore, our inequality, -3 less than 0, which satisfies the given inequality. So that means our result is true.
And then for the third interval, I will be using +4.
Now, let us try to test the point value 4 if it satisfies the given inequality x squared minus 2x minus 3 less than 0 by substitution method. So let us now substitute 4 to the variable x in the given inequality. We now have 4 squared minus 2 times 4 minus 3 less than 0. Perform the indicated operation. 4 squared, that means 4 times 4. This will now become 16. Then -2 times 4, that gives us -8 minus 3 less than 0. Simplify 16 minus 8, that is 8 minus 3 less than 0. 8 minus 3, that gives us 5 less than 0. It does not satisfy the given inequality. That means it is false.
4. Step 4, we have to illustrate the solution set. So to illustrate, we have to use the number line that we have created in step 2. So I have here the number line. Next is for us to shade the interval that contains the point that satisfies the given inequality. So please take note that in step 3, in test point, interval number 2 contains the point that satisfies the given inequality. Therefore, we have to shade interval 2. So I have now here the illustration of the solution set. Next, step 5 is to write the solution set into interval notation. So now the solution set is -1, comma 3. Please take note that we are using parentheses since the given inequality is less than, and we are using an open circle, which also means that -1 and +3 are not included to the solutions. So that was example number 1. Let us have another example for a deeper understanding. Example 2. Illustrate and solve the quadratic inequality 2x squared plus 3x minus 2 greater than or equal to 0. The first step is for us to make the inequality into an equation and solve for its roots. So we now have 2x squared plus 3x minus 2 is equal to 0. So this quadratic equation can be easily solved using factoring. So I have here now the asterisk method. The first step that we have to do is to find the value of our a and c, then multiply it. So I have here ac is equal to -4. The value of our a is +2 times the value of our c, -2. That gives us -4. Next, we have the value of our b is +3. And then, we need to find factors of -4 that if added, the result is the value of our b, which is +3. So those factors are -1 and +4. Please take note, -1 times 4, the result is -4. And then if we add those factors, -1 plus 4, the result is +3. Next is for us to divide those factors by the value of our a, which is +2. Divide and then simplify, then change the sign so that we can get the values of our roots. -1/2, that is already simplified, change the sign, the result is +1/2. Next, we have 4/2, that gives us +2, change the sign, that gives us -2. So the roots now are +1/2 and -2. Step 2, plot the roots on the number line. So we have now here a number line. Plot the roots that we had. In step 1, we have +1/2 and -2. And please take note, we use closed circle since the given inequality is greater than or equal to. So now, our number line is divided into 3 intervals. The first, second, and third interval. So for the first interval, from -2 included to -infinity. And for the second interval, we have from -2 included to +1/2 included. And then for the third interval, we have +1/2 to +infinity. Step 3, we have to test points under first, second, and third interval. So let us now have our graph, our number line, and let us have a test point value for the first interval. Let us have -3.
Now, let us try to test the point value -3 if it satisfies the given inequality 2x squared plus 3x minus 2 greater than or equal to 0 by substitution method. So now, let us try to substitute -3 to the variable x in our given inequality. This will now give us 2 times negative 3 squared plus 3 times negative 3 minus 2 greater than or equal to 0. Perform the indicated operation. 2 negative 3 squared, that gives us negative 3 times negative 3, that is 9. 3 times negative 3, that gives us negative 9, minus 2 greater than or equal to 0. Perform the indicated operation. 2 times 9, that is 18, minus 9 minus 2 greater than or equal to 0. So 18 minus 9, that is 9 minus 2, that is 7, is greater than or equal to 0. Therefore, it satisfies the given inequality. That means it is true.
And for the second interval, let us have 0.
Now, let us test the point value 0 if it satisfies the given inequality 2x squared plus 3x minus 2 greater than or equal to 0 by substitution method. Now, let us substitute 0 to the variable x in the given inequality. So, this will now become 2 times 0 squared plus 3. Our x becomes 0 minus 2 greater than or equal to 0. Perform the indicated operation. 2, 0 squared, that gives us 0. 3 times 0, that is also 0, minus 2 greater than or equal to 0. 2 times 0 is 0, minus 2 greater than or equal to 0. This is now negative 2 greater than or equal to 0, which does not satisfy the given inequality. Therefore, it is false.
0. And for the third interval, let us have
Let us test the point value 1 if it satisfies the given inequality 2x squared plus 3x minus 2 greater than or equal to 0 by substitution method. Now let us substitute 1 to the variable x in the given inequality. This will now become 2. Our x becomes 1 squared plus 3 times 1 minus 2 greater than or equal to 0. Perform the indicated operations. 2, 1 squared, that is 1 times 1, that gives us 1. 3 times 1, that gives us 3, minus 2 greater than or equal to 0. 2 times 1, that is 2, plus 3 minus 2 greater than or equal to 0. Simplify. 2 plus 3, that is 5 minus 2, that is 3 greater than or equal to 0, which satisfies our inequality. That means it is true.
have step 4, illustrate the solution set. To illustrate, we have to use the number line that we have created in step 2. So we now have here our number line. Next is for us to shade the solutions or the interval that contains the points that satisfy the given inequality. So please take note that in step 3, in test point, interval 1 and 3, or the points under those interval, satisfy the inequality 2x squared plus 3x minus 2 greater than or equal to 0. Therefore, we have to shade those parts or those intervals. So we now have here, and this shows now our solution set. Now, for the step 5, we have to write that solution set into interval notation. So the solution set now is negative infinity, comma, negative 2, union, 1/2, comma, positive infinity. Now, please take note that we are using parentheses here for the negative infinity since it does not contain the endpoints of our solution. And for negative 2, we are using the bracket since negative 2 is included to the solution of the given inequality. Same with 1/2 is included to the solution. And for the positive infinity, parenthesis since it does not contain the endpoints. So that was example number 2. So let us be reminded of the following steps in solving and illustrating quadratic inequalities in one variable. For step 1, we have to make the inequality into an equation, then solve for its roots. Step 2, plot the roots on the number line. Step 3, we have to do the test point. Step 4, illustrate the solution set. And we have to write that solution set into interval notation.
So that was solving quadratic inequalities. Thank you for watching, and I hope you have subscribed to our YouTube channel for more mathematics discussion videos. Bye!